Okay, so we're going to be finding the domain, minimum, maximum, increasing, and decreasing intervals from this equation. Our equation we are given is f of x is equal to ln, and then the absolute value of x squared minus 18x minus 40. So the first thing we're going to find is domain, and that's pretty easy. It's just what's in here. So it's x squared minus 18x minus 40. Why is it doing that? Okay. So now, because we have an ln at the front, ln of 0 does not exist, so we need to find out when this equals 0 so that it can become an asymptote. So we're going to use the AC method. So we're going to have negative 40 and negative 18 right here. And we find that negative 20 and 2 multiply to get negative 18. So then we're going to have x minus 20 times x plus 2. And we're going to set those equal to 0. And we get that x cannot equal 20 or negative 2. Now we're going to find any other numbers that will be on the number line. And we're going to do this by taking the derivative. So we're going to do f prime of x. When you take the derivative of an ln, you first do 1 over what is inside the ln, which is x squared minus 18x minus 40. And then you are going to take the derivative of this and put it up top. So we get 2x minus 18. That gives us 2x minus 18 over x squared minus 18x minus 40. So now we're going to find out when that equals 0. So it would equal 0 when up top is 0, because 0 over something is always 0. So we're going to take 2x minus 18 equal to 0. And we get that x is equal to 9. So now we're going to create our number line. And we're going to have 20. We're going to take up these up here. We're going to have negative 2 right here. 20, and then we're going to draw lines to remember that they are asymptotes, and then we're going to put 9 right here in the middle. And 9 is not an asymptote because 0 can exist in this equation right here. So now we have almost everything we need to find everything. First, we need to figure out if it's positive or negative in between these intervals. So I'm going to take an interval that's lower than negative 2, so negative 3, and plug it back into this original equation. When I do that, I get that it's a negative number. You don't have to know the exact number, just whether it's negative or positive. I'm going to plug in something in between 2 and 9, so 0 is probably the easiest, and I get a positive number. I'm going to plug something in between 9 and 20, so 10, negative, and then between 20 and infinity, so 21, and it's positive. So now we have almost everything. So first we're going to do our increasing and decreasing intervals. So the interval is increasing when it's in between, when in between it there's a positive. So here and here and here and here, and it's decreasing when there's a negative in between. So first we're going to start off, we're just going to go left to right. So it's decreasing from negative infinity to negative 2. And then it is increasing from negative 2 to 9. It decreases again from 9 to 20. Whoa. And then it increases again from 20 to infinity. Now to find our minimum and maximums. So when it goes from positive to negative, it is a maximum. When it goes from negative to positive, it's a minimum. If you go from negative to positive, minimum. So that's why it makes sense. When you have a vertical asymptote separating two of the negative positive, it doesn't count as a minimum or maximum. So this in between and this in between doesn't count, but this one does right here. And it's going from positive to negative, so it's a maximum. First, we're going to write that there's no minimum. We still have to write none. And then for maximum, for maximum, we're going to have 9 because that's the interval it's on. And then we're going to plug 9 back into this original equation. So we're going to have ln of 9 squared minus 18 times 9 minus 40. When we put that all together, we get ln of 121. And that is how you find increasing, decreasing, minimum, maximum